Hello, boys and girls. Welcome back to Science with Miss Saulter. Today we are on lesson 3 of our student activity packet. Our third lesson is Newton's Laws Experiment. So you need this packet with you today. You don't need these materials. I'm going to be demonstrating the experiment, but you do need to have done these warm-up questions. So if you haven't done these yet, you can go ahead and do them now. Pause the video and go ahead and do them now. And then unpause and we'll go over them. So I'm going to go ahead and start with our PowerPoint and we'll get to those questions in just a second. All right. So this week, the week of April 20th, we'll be checking out Newton's Laws Experiments. There's a nice little picture of Isaac Newton there. All right, the assignments this week, you're supposed to watch a brainpop.com video about Newton's laws of motion and then take the quiz at the end. The username and password is right here. I'm also going to be showing the video during this video, a video and a video. So if you want to watch it right along now, you can. If not, maybe you've already watched it. All right, so you do need your student activity packet warm-up questions. Our learning target, our focus today is I can perform an experiment to show how Newton's 3 laws of motion work. So let's do a quick review. Newton was a scientist from the 1600s. He lived a long time ago. He's no longer alive today, but the things he observed and the things that he came up with, the 3 laws or rules, are still relevant today. He used these 3 laws or rules to explain what forces are and how forces cause motion. So that first law, the law of inertia, is an object's resistance to change in motion. So law 1 states that an object needs force to be moved or stopped. Remember we talked before about a force being a push or a pull. Think of like a soccer ball in a field. It's just an object at rest and it's going to stay at rest until a force acts upon it. Or it's going to stay in motion until a force acts to stop it. The second law is the law of acceleration. Acceleration is the change of speed or direction of an object. Law 2 states that forces can slow down, speed up, or change the direction of an object. So that push or pull can slow something down, speed it up, or change the direction. Law 3 states that if 2 objects come together, there will be a reaction to the action. This means that if one force acts, then the opposite force will push back. So just for every action, there's an equal and opposite reaction. All right, we are gonna first actually go over our warm-up questions and then we'll get to this brain pop video. So hey, I'm back. So we are right here on our page. We're gonna go over these warm-up questions 1, 2, and 3. If you haven't done them, guess what? You get to do them now, or you can go over them with me now. So these are just kind of some questions to get you thinking. So the first question says, what's one thing you could do to add force to a marble that's still to get it moving? So in just a little bit, we're going to do our experiments with the marble. So there's a marble that's going to be sitting still on the table. What's one thing that you could do to add force to the marble? So you could maybe push it with the pencil, you could flick it, you could pick it up, any of those things, any types of push or pull to get that marble moving would be a good answer. Number 2 says, if the marble is rolling, what is one force you could do to stop it from moving? So once something's rolling or moving, what's something you could do to stop it? So you might say, pick it up. You might say, block it with your hand. You might say, catch it in a cup. Anything pushing, pulling, grabbing, anything to stop it would be acceptable. And number 3 says, which law of motion states that an object needs force to start or stop a motion? Check out those notes from lesson 2 if you need to. So which law is that? First law, second law, third law? I would say the first law is the one. An object at rest is going to stay at rest until a force acts to move it, or an object in motion is going to stay in motion until a force acts to stop it. So that would be number 3. All right, moving on. We are going to watch our brain pop video, then we'll go over this experiment right here. So let's see if I can do some screen sharing here. So we are going to watch Mysteries of Life with Tim and Moby, Newton's 3 laws of motion.
Thanks, Moby. Hey, Tim and Moby. Can you tell me about Isaac Newton's 3 laws? From Jerome. Well, Isaac Newton was a scientist who lived in the 17th century. We have a whole movie about him, so you should check it out. Anyway, Newton came up with the 3 laws of motion that can be used to explain how and why stuff moves. Well, yeah, these laws are still in use today, so I'd say he was pretty smart. Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest unless an unbalanced force acts on it. You probably don't think about it this way, but when a car is moving, everything in it and on it is moving along at the same speed. If the car has to stop suddenly, the objects in and on the car will continue moving forward. Guess we should have tied those on tighter. An object's forward motion will continue until an unbalanced force acts in the opposite direction to stop it. So, our seatbelts provided the unbalanced force that stopped our bodies from moving forward. But those ropes didn't provide enough force to balance out the ski's forward motion. Why didn't it keep going? Well, in this case, the force acting on the rock was friction. Friction is the resistance caused by any 2 objects in contact, and it always acts in the opposite direction of the motion. Newton's second law says an object that has an unbalanced force acting on it will accelerate in the direction of that force. When you're just sitting there, 2 forces are acting on you all the time. Right now, gravity is pulling our mass toward the center of the Earth, and the upward normal force of the ground is pushing up against gravity. We could sit here all day and go nowhere because these 2 forces cancel out. This hill is a different story. At this angle, gravity and the normal force are not canceling each other out. Gravity wins, and we accelerate. The net force that's acting on us and making us accelerate is a combination of the normal force and gravity. Look, friction. Newton's third law is this: forces always occur in equal and opposite pairs. When I pushed that door, it pushed right back at me with equal force. The door was the one that moved because friction between my feet and the floor combined my mass with the building's mass. The door is on hinges, which decrease friction, so it accelerates open. Maybe if you took off your roller skates. Or not. Oops. Well, that's about it for Isaac Newton's laws of motion. I'm gonna get Moby an ice pack.
All right, so I hope you guys enjoyed that. You know, I like the cheesy videos. All right, so here we go. We are on experiment part 1. That first page. Let's see if I can get you guys over to my camera on my phone. All right, so here we go. I got my own little demonstration going here. So I am using this marble launch. You should have had this in your packet that got sent home. If you don't, that's okay. But I'm going to demonstrate it now. Again, these experiments are optional. You do not have to try them at home, but if you did want to, they're safe to try at home experiments. Girls, we are back. We are going to try experiment part 1. So you should have this page open in front of you that says experiment part 1 at the top. I'm going to go ahead and demonstrate this for you. So right here we have a marble in our rectangle, our starting spot, and then we have some marbles over there in a circle. So these marbles are all considered objects. Everything's an object. So an object, are these at rest or in motion? They're at rest, right? So an object at rest is going to stay at rest until a force acts upon it. So I got my little pencil here. Let's see if I can apply a force, and I'd like you to observe what happens. Okay. All right, there they go, off the table onto the floor. So on your paper, I would like you right here to describe what happened to the 3 marbles in the center circle. So take a second to fill that out. Okay, you might say something like, you know, the marble hit them and caused them to go in another direction. You might say The marbles scattered, the marbles moved out of the circle in different directions. The marble that wasn't hit at all is still at rest. See, that little guy's just staying there. The question underneath that says, did all the marbles go in the same direction? Did they all go in the same direction? No, they kind of went all over the place. So underneath that, the first law of motion states that an object needs force in order to move or stop. What object was the force that caused the marbles to move? So part of that might be, you might say the eraser of the pencil was the force that caused that to move, the push from Miss Saulter. But in reaction to that, the starting marble or the launching marble was the force that caused the center marbles to move. So once that object was in motion, it hit those other marbles and caused them to move. So you would say the launching marble for that. Girls, so now we are in experiment part 2. It looks like this. So on the next page, I'm going to go ahead and demonstrate this for you. We have our same starting marble here. We have 3 marbles in the circle, and then I have a blocker at the end. In our experiment, they said to use a ruler, but I had a rolling pin handy right here. So I thought I'd go ahead and use that. So what I'd like you to do is describe what happens to the 3 marbles in the center of the circle this time, and think about what's going to happen with the blocker there. Okay, ready, aim, fire. There they go. Good. All right, so describe what happened. I know, not super exciting, but I'm going to keep going. So this says, describe what happened to the marbles in the center of the circle. So the marbles in the circle hit the rolling pin and then they changed direction. So some of them just got stuck right there. Some of them rolled off in a different direction. Underneath that, it says the second law of motion states that force can slow down, speed up, or in this case, change direction of an object. Which force in this experiment caused a change in speed or direction of the marbles? What do you think? What was the force stopping it? Yeah, for me, it was the rolling pin. Maybe you used a ruler or something else at home, but that rolling pin is what caused the speed and the direction to change. So thinking about when something hits something else, it's going to cause it to change speed, change direction, slow down, speed up. We have our marbles on opposite sides, and we're going to see what happens when they collide. Cool. Whoop. There they go. Off the side of the table. All right, so what happened to the direction of the marbles when marble 1 and 2 collided? Did you guys see what happened? So the marbles definitely changed direction. They kind of pushed in opposite directions. And then with the slope of my table, they both ended up rolling off. But they had that equal and opposite reaction. One pushed a little further than the other. So it had a stronger push than the other one. So it just went ahead and pushed it further. Down at the bottom, it says the third law of motion states that if one force acts on an object, an opposite force will push back. When the force of marble 1 hit marble 2, what force was pushing back on marble 1? Yeah, the force of marble 2. So they were pushing against each other. They had that kind of equal and opposite reaction when they hit. So you, again, are welcome to try these at home. Use any materials that you have. You can do it with 4 soccer balls if you want to try it outside. What happens when one soccer ball hits the other soccer balls? Or, you know, any type of balls or anything that rolls that you have at your house. So going back to this, I can perform an experiment to show how Newton's 3 laws of motion work. Think about that. Were you able to see that in each one? Was there an object at rest that stayed at rest and a force moved it? Yeah. Was there equal and opposite reactions? Yeah. Did a force cause it to change direction? Yeah. So go back over those if you need to. And that's all I have for you guys this week. For next week, our lesson 4 is on gravity and friction. So for next week, I'd like you to watch the Brain Pop video, Gravity, and take the quiz. And in your student activity packet, look over lesson 4 and become familiar with it. So that way, when I demonstrate those, you'll be familiar with them. those are actually pretty fun ones too. It's building a ramp and launching stuff down it. So if you want to do that one at home, you're welcome to try them. Totally optional, not required, but it might be something fun to try out and see. And then there's even an extension to that that tries different types of surfaces to see friction in action. So feel free to try those out. But I'll be demonstrating those next week. And I will try to get that out to you earlier in the week than Wednesday. Hopefully have it out to you by Sunday so you can watch that anytime that works for you. If you have any questions at all, please feel free to reach out, and I'm here for you guys. Keep emailing those assignments. Good job turning those in, and yeah, just let me know if you need any help or have questions or anything. But I hope you guys are doing good, and I will talk to you soon. Bye.